Let us solve the equation x cube minus 3 plus root 3 times x plus 3 equal to 0. So we want to solve this equation. Let's write this equation as equation 1. You see that maybe x equal to root 3 is a solution. Taking x equal to root 3. When I take x equal to root 3, in equation 1 what do you get? Root 3 whole thing cube minus 3 plus root 3 times root 3 plus 3. That must be equal to 0. That is, root 3 cube is root 3, you know that root 3 square into root 3. That's equal to root 3 cube. But root 3 square is just 3, so 3 root 3. So root 3 cube is 3 root 3. And then if I multiply it, 3 root 3 as it is, minus of root 3 into root 3 is 3, plus root 3. We want this to be equal to 0. Is that true? 3 root 3 gets cancelled. Oh, I wrote it wrong. So it's 3 here, not root 3. Yeah, so you see that 3 also gets cancelled. So, okay. Therefore, I can say that x equal to root 3 satisfies the equation 1. Since x equal to root 3 is a solution of this equation, we must have x minus root 3. Once again, since x equal to root 3 is a solution of equation 1, x minus root 3 must be a factor of this polynomial. So let's factorize this polynomial. X cube. First of all, we write equation 1 once again. Minus 3 plus root 3x plus 3 equal to 0. We know that x equal to root 3 is a factor. So we try to factorize it. This is equal to x cube minus root 3 into x square. Once I write minus root 3 into x square, you see that x minus root 3 is a factor of this polynomial. But we want the equality maintained. So I'll add plus root 3x square. So I'm maintaining the equality. But again, I have to subtract something so that I get x minus root 3 as common. So root 3 is there. So root 3 into root 3x. So when I take root 3x common, once again I'll get x minus root 3 as a factor from this polynomial. So okay, but root 3 into root 3 is 3 minus 3x. So I don't have to add those. Oh, I have to just write minus root 3x. Because 3 gets absorbed, but minus root 3x left out. Plus 3 as it is, equal to 0 as it is. You can see that you can take x minus root 3 common from here as well. So let's take x minus root 3 common. When I take x minus root 3 common, I'm left out with x square and then root 3x and then minus root 3. I see this is a product of two polynomial. One of them is linear, x minus root 3. Other one is quadratic. And if product of two number equal to 0, one of them has to be 0. Therefore, either x minus root 3 equal to 0 or x square plus root 3x minus root 3 equal to 0. Now, if x minus root 3 equal to 0, that's very simple stuff. We just have to take root 3 to the right hand side and we get x equal to root 3, which we have already observed initially that x equal to root 3 is a solution of equation 1. What about this one? We compare it with the quadratic equation ax square plus bx plus c equal to 0. This is a quadratic equation. Roots are given by x equal to minus b plus minus root over b square minus 4 into a into c, a equal to 1. And divided by 2a as well. Here b equal to root 3, so minus root 3 plus minus root over b square, so root 3 square minus 4 into a is 1, c is minus root 3. divided by 2a. A is 1. So that's equal to minus root 3. Plus minus root 3 square is 3. Minus minus plus 4 root 3 divided by 2. Therefore, solution to the given equation are x equal to root 3, comma x equal to minus root 3 plus 3 plus 4 root 3 square root of 3 plus 4 root 3 by 2, comma minus root 3 minus square root of 3 plus 4 root 3 by 2. Can you simplify this quantity square root of 3 plus 4 root 3?